How's it going, everybody? Today we're going to do some machining. We're going to be machining some of these parts right here. We made a few changes to them. So this one's going to stay the same. So this is for a trans cross member mount. This one I'm going to make it a little bit thicker this time, out of some thicker material to give a little bit more bite for the threads. And I'm also going to countersink the bolt basically to where rather than relying on just the thread of the bolt, we'll be relying on some of the shoulder. So I'm probably going to put like probably an 1/8 inch, maybe 3/16 of a counter bore right here to allow for the shoulder of the bolt to actually sit and take some of that load, so it's not relying on the sheer load of just the threads right here. So we got all our material cut up. So these are going to be these pieces right here, and then these are going to be the thicker pieces. You can see we did these at a 1/2 inch. This is a 1 inch thick 4140 chromoly. So we're going to make them a little bit thicker and just try to update the design a little bit, make it better. So don't mind the bench. The bench is a mess right now. I haven't really had time to clean stuff up since our last desert trip, so I'm probably going to work on that today as well. So we're going to deburr. Since we got these cut, you can see that little edge right there, which we've talked about in our last video. You want to get rid of that. That way it holds it in the vise real nice. So we'll go ahead and deburr them and go from there. So that one's all done. So again, we're going to use our Milwaukee right angle die grinder with a Scotch pad on it, red Scotch-Brite pad. So I love this thing. If you guys don't have one of these and you're looking to get one, I highly recommend these. We've used Air forever, and I'm actually really like this because I can take it in and out of the trucks, in and out of, we can take it with us when we go to the desert in case we need it. It's just really universal, and it has a lot of power for what it is. So this material was pretty good. As you can see, it's already been precision ground, so we're not too concerned with squaring it up. We just wanted to get it deburred, that way it holds in the vise real good. So all our material's deburred. So we'll go ahead and we'll go put it in, get it set up on the parallels in the machine, get the programs ready, and go from there. So I already got my parallels set up on this vise. This vise, I gotta clean it. It's pretty clean from the last job, but I want to clean the parallels off, make sure there's no material in between the jaws and stuff like that. Got that all cleaned up, so we'll go ahead and put our material in here now. So we're going to do our 1/2 inch plates first. Set up. This one. Alright, so we got those bolts put in there, everything looks good. So we'll go ahead and do our X, Y, Z offsets on both of these. and we'll go ahead and machine them. Alright, so we got the probe all set up. So now we just got to put in our measurements, which is a 4.5 by 2.5 by 1/2 inch block. So we'll put that in. We'll get our G54. So this is going to be G54, G55. We're on 2 parts at a time. So let's go ahead and get that set up. So that's our G54. Now we're gonna move it over to the second part and do G55. That's about center. So now we're gonna go in here to MDI. We're gonna go to edit, and we're just gonna come up and change this G54 to a G55. All right, so we're ready to go. So our G55 coordinates all done. So we're gonna come in here, we're gonna go to our list programs. We're running program 1151. We're gonna select that program, we're gonna come over to memory. So as you see, it says 2-inch tube clamp, and that says op1. So we should be ready. I'm gonna change my rapids to 5%. And then I really like this because when you're milling steel, these tools are meant to run dry, so you don't got to run coolant. We do run coolant on our chamfer tool just to extend the life on it. Change our rapids until we get the tool in here. Go to 25. I always hit feed hold to make sure I'm right above the part. So now that I know my part's in the right spot, we'll let her run. So our step over was right at a 1/2 inch. I changed it to 0.45. I don't know how that got changed. I was messing with the program a little bit, but I didn't change any of that stuff, so we just changed it. Now it's good to go. So right now it's facing the part, and then it's going to come down and start doing the rest of it. So it's coming down in a helical motion. It's going to start doing that bore. So they say when you're cutting 4140, you want the chips to come off almost like a straw color, and then when they hit the pan, you want them to turn to like a purplish color. So as you can see, they're coming off a little bit darker probably than we want, but that's all right. Come over to the next one because I got it to do operation by tool, so it's going to face it. Could probably speed it up a little bit. I changed the feeds and speeds a little bit. So now it's going to come down and grab the drill. This is a 3/8 drill bit. I do use coolant on the drill bits. So we're doing a partial pecking motion, which basically breaks the chips. So it'll come down, retract just a little bit, and make sure it breaks the chips out of the way so it doesn't clog up the drill bit in the hole. So it should come back up and grab the 1/2 inch tool again, and it's going to do its adaptive now. Or it's going to pocket those holes, sorry. So this is going to do a counter bore. That way the 12-point bolt has a nice pocket to sit in, and it won't take rock hits and stuff like that, being that it's underneath the truck. So now it's going to do the adaptive here. Now it's going to come down and grab the chamfer tool. So we're leaving 20 thou radial stock. That way we can put it in the fixture, and we'll machine the rest of that hat off. And it'll also do a contour around the outside to smooth it up and make sure it's all good. So the fixture we made for these parts, it'll actually be the fixture for both halves of the part. So we'll do the other part, and then we'll put the fixture in, and we'll run the final ops on them after this. So the chamfer is a little bit big, but that's because we still got to come outside and do a contour. So right now I left 20 thou stock on the outside, and then when we come down and do this hat, it'll get rid of all that. But we mainly want to do the face of the part and all the inside of the part, because once our fixture uses bolts to hold it in the fixture, so you can't get to these pockets. So we'll go ahead and do that, and then we use this pocket as our XY coordinate, and then the top of the part will be our Z. So we'll get the other part going and go from there. Alright, so we got our vices all pretty clean. So we're going to go ahead and set up our next stock right now. So this is our 1-inch chromoly. So everything's in the place, so we'll go ahead and do our G54, G55. Center of the part's going to be our work offset again, just like the other ones. So let me get the probe pulled up and we'll run that off. Alright, we got the probe pulled up. So we'll come over here and get it to the center of our part real quick. Roughly center. Come down to about 1/4 inch off the part. You measure it again just to be sure. So we got 4.5 by 3. So because we can just edit this again, so we're gonna do 54, and then we're gonna have to come down and change our stock. So it's gonna be 4.5 and 3.0. Everything else should be good. Alright, so we should be ready to run it. So it's going to be G54 right now. So G54 is done, now we're going to do G55. Alright, our G54 and G55 offsets are set. We got to change out a few tools just because this one has a 3/8 tapped hole, and I got to change out the drill bit as well for this one. So let me get that all done and we'll run our program. Alright, here we go. We got all our tools set. So we're going to go ahead and run it. Fixture all in. Our program number is 1152. I like to write it down on the parts sometimes for the second op. So we're going to do that bore. That's going to be our XY, and then our Z is going to be the top of this face. So let's go ahead and do that. Found center. So now we're going to go up. We're going to come over and do this face right here. All right. There's the face. I'm going to load the program now. So it's going to be 1152. Select program, memory. Program. I'm going to make sure that the XYZ offsets are good before we start it. Alright, here we go. Alright, that one's done. Nice finish on the outside, chamfer looks good, everything looks good. So I'm going to go ahead and unbolt it and we'll put the next one in. So now we just got to deburr that edge real quick, but that'll be easy. Here's the second one. Wanted to deburr that edge for when it drilled real quick, just so it sits nice on the fixture. Alright, second one's done. Done. We'll deburr it real quick. It's almost falling off, as you can see. On this part, you can see our XY coordinate is going to be this hole right here, and then our Z coordinate is going to be this face. So what I'll do is I'll come in here, I'll stick the probe ball into this hole, do the XY, and then I'll put the part on. And then we'll do the Z off the top of this face, and then we'll be able to machine that. Alright, go ahead and run it. So I'll move this out of the way, get the part on, then we'll come back and do the face. Got a couple washers, so I don't have to thread it in so far. See, we went a little bit into our fixture, which really doesn't matter. I could change those heights offset a little bit, and then eventually I want to get like a backside chamfer tool to where if we make this fixture a little bit smaller, we can actually chamfer the backside of the parts. So that'll be nice in the future. But this one's done. Take that one off and go to the next one. I didn't show it in the camera, but we did do a little counter bore. So you can see there's a counter bore right there. So that way you can, the shoulder of the bowl will actually sit in that counter bore and you're not going to be relying on the threads. Alright, second one's done. Looks good, finish looks good. Because this was a precision ground face, I didn't see a need to come back and machine it. This is getting welded onto a flat plate. You can see this registers in there and it slides in like that. So we'll deburr it, get everything cleaned up, and go burn it on the truck. Alright, so we're all done. We got it deburred. Probably gonna clean this face up a little bit just because it does sit on that. But if you look at, you can see the difference between the thickness from that part to that part. So we're almost, almost probably a 1/4 inch thicker. So that way, we can still have enough thread engagement, but as well as has that bore to where it'll take the load off the threads and put it on the shank of the bolt. So that's all. All right, everybody, take it easy. We'll show it to you when it's on the truck. All right, so we got these all in. We got our trans mount all welded up. It's not welded to the tube yet, but it's bolted in place and clamped in place. So these are all tacked in. I'm gonna go ahead and weld them now. So you guys can check it out. All right, let's go ahead and weld her.
opted to TIG weld this just because it's easier to get a lot of heat and penetration into this thick piece of material versus just trying to MIG weld it. So that's kind of why I did this. And then also I weld the plate to the frame first. I'll do that on both sides, and then what I'll do is I'll weld it to these bungs, this piece that is removable, and then last I'll do the actual trans cross member mount to the tube. The reason I do it that way is because if any of these move at all, I want them to move now versus welding this and then these move and then your bolts don't line up. So I have a process. That's how I've always done it. It's always seemed to work for me. So that's just kind of the way I do things. But you know, everybody has their own little tricks and stuff that they do. So, but we'll go ahead and weld this side right now, and then we will, once those cool, we'll go ahead and burn the tube all the way around. Make sure everything removes nice, and then I'll come back and I'll probably just MIG weld this because there's no reason to TIG weld it. It's already all MIG welded. So go from there. I always tell everybody the big thing to getting a good weld is being comfortable. If you're not comfortable, your weld's gonna look like crap, even if you're a good welder, in my opinion. So always try to get as comfortable as you can, because when you're comfortable, it makes you less tense and you're not twitchy and stuff like that, so you actually can weld better. That side's all done. I will second pass this bottom. I left a little bit of a, I don't want to say a gap, but like a edge to fill, because I wanted to get it as close to the bottom of the frame as I can, because there's going to be more lateral bracing that comes back and ties into the bulkhead, so it'll spread that load if he were to stuff. So if the driver were to ever stuff the bulkhead into the ground, it'll actually transfer that load through the bulkhead into the chassis. So I'll let these cool down, and then I'll come back and weld around here. And then once that cools down, I'll MIG weld the trans cross member. So, alright, thanks for watching. We'll add some pictures when it's all done.